That was inductive reasoning. Now we're going to turn to deductive reasoning. And we won't be studying abductive reasoning in the same way because, as I said, abductive reasoning is messier, involves considering multiple kinds of evidence and drawing different kinds of conclusions towards the best working hypothesis. Abductive reasoning is probably a better description of what really goes on in science. Deductive reasoning is traditionally associated with mathematics. It's reasoning according to rule, and it's a tradition that goes back to Aristotle. It's usually associated, therefore, with logic, although logic is now a branch closely related to mathematics, and it's not clear that the formal logic is a good description of anything that we do. But there's been a much more research done on deductive reasoning than on inductive, and almost none on abductive reasoning. So reasoning should not be seen as a single thing or a single faculty. One reason that there's been more work done on deductive reasoning is that it's easier to do. That's very unfortunate when we just go for the low-hanging fruit. But inductive reasoning requires a great deal of preparation, past experience in order to draw a conclusion, whereas deductive reasoning tends to be, here's a logic puzzle, solve it, get it right or get it wrong. Even the 2-4-6 task, that was an example of inductive reasoning, of drawing conclusions based on the guesses that you'd made so far. So in deductive reasoning, we are reasoning, so we're not just using symbols, we're using words. I would say sentences, except that sentences are part of language. They're part of the means by which we communicate. There's a special kind of way of understanding some kinds of sentences which are used in deductive reasoning. They're called propositions. And the logical relation which links propositions is known as implication. That is, what is implied by one proposition or one set of propositions. So this is very, very formal. The kind of logic that's employed is called propositional logic because we're using propositions or statements. And it uses a very few forms. So if some proposition, then some consequence is an example of the kind of reasoning that goes on here. Or if some proposition, only if some proposition, consequences ensue. And the little logical terms not, and or are also used. We don't have time for a deep dive. We're just going to meet the very simplest kinds of deductive reasoning here. The proposition is a sentence which is assumed to be either true or false. It is simply not the case that most sentences are either true or false. This is a way of using sentences in debate, in argument. So given several propositions, which are assumed to be true, question is, what can we deduce from them? And we're going to follow a very limited paradigm, a set of 4 kinds of logical inference, 2 of which are sound, 2 of which are good ways to reason, and 2 of which are unsound, or bad ways to reason. And in each case, we're going to link 2 propositions to, so if P, then Q, and P in the present example. So P can stand here for any proposition, like the cat is on the mat. And those 2 propositions, if P, then Q, and P, are independent assertions. And modus ponens refers to the valid conclusion of Q based on these 2. So let's have an example. We've met the infamous syllogism from Aristotle. We have to modify it slightly to fit this format. But the first proposition, if P then Q, becomes, if Socrates is a man, then he is mortal. And we haven't done any reasoning yet. We're merely setting up the game. So Socrates is a man is the proposition P. He is mortal is the proposition Q. We're not claiming anything at all about Socrates, in fact, except that if he is a man, then he is mortal. The second proposition, P, look at it, it's identical to the P in the first one. Socrates is a man. We're now asserting that Socrates is a man. So the first one is just setting up the game. The second one makes an assertion. And if we assume that both of those are true, then we are justified in deducing that Socrates is mortal. I think that should be screaming the obvious to you. The reasoning that's involved in going from those two statements to the final statement is perfectly clear and should give no cause for concern. Modus ponens is the simplest of these forms, and we'll file it under blinding the obvious, shall we? Here's a very similar logical structure called modus tollens. Here, the first proposition we're going to consider is, again, if P, then Q. The second proposition, or the assertion, is different this time. It's not Q. And given those two, we can validly conclude not P. So let's fill in the values of P and Q. Let's let P stand for there is fire, and Q stand for there is oxygen. So our first statement becomes, if there is fire, then there is oxygen. Not Q, the second assertive statement, says there is not oxygen. Now, given those two, if those two are true, then it is reasonable to conclude that there is not fire. I hope you can follow that train of reasoning, but I hope you can see that it's just a little bit more complex than modus ponens. Modus ponens was duh. Modus tollens, you need to work a little bit more. And you can see here, I hope, what game Aristotle was introducing to the world for the first time, at least the Western European world, or Middle Eastern as it was at the time, which is the use of symbols, P and Q and so on, which are not themselves statements about the world, but which can be filled with many different kinds of statements. They can be put into this form, if P then Q, not Q, therefore not P. They can be put into this form to allow certainty in reasoning, even as the values of P and Q change. So there's the two of them together, if P then Q, and the assertion P allows us to deduce Q. If P then Q, not Q, allows us to assert not P. And these are both very valid, and people tend to be better at using modus ponens than modus tollens. Now, having become enshrined in the Western mindset as a form of reasoning, of logical, good, deductive reasoning, these kinds of arguments have played an outsized role. And so one might reasonably ask, well, are people good at reasoning? So you can try it out for yourself. Here's something which is similar to what we've just seen. If Susan is angry, then I will be upset. I am upset. Therefore, Susan is angry. Have a look at that. Think about that. Now, to put that into one of the forms we've seen, Susan is angry can play the role of P. I will be upset can play the role of Q. I am upset is still Q. The conclusion here is not P. That is actually not one we saw. Let's just go back and forward. The second proposition here, I am upset, asserts Q. The inference drawn is that P is correct. That doesn't match either of those two patterns. So we're dealing here with something that looks like logical reasoning and is actually wrong. We have a special term for that. We've a term logical fallacy. This looks a lot like modus ponens and modus tollens, but it leads us to an invalid inference. We've got two of those we're going to look at, and they're both very similar to modus ponens and modus tollens, but they're different and they lead to mistakes. So affirmation of the consequent, don't they have fancy names, is like this. We start off with an initial proposition like if P then Q, and we assert Q, and then we deduce P. That's the one we just saw. This is not a valid reasoning. Here's an example that I think might make it clearer. So suppose the first one, if P then Q. For P, let's substitute I do well in the test. For Q, let's substitute I get drunk at the weekend. So what's this going to look like then? If I do well in the test, I will get drunk at the weekend. Now we assert Q, I got drunk at the weekend. and we conclude, therefore, I must have done well on the test. I hope you can see that's not good reasoning. You could have got drunk on the weekend anyway, even if it's true that you would have got drunk if you'd done well on the test. So this is an example of a fallacy, and yet the steps involved are very close to those for some valid reasoning. So you may have done well on may or may not have done well on the test. That doesn't say anything about whether you will get drunk at the weekend. So it's a flawed argument. Affirmation of the consequent is the first one. Denial of the antecedent is the second one. Where do these funny names come from? Well, let's look at the affirmation of the consequent. Notice the second proposition here is Q. We are affirming or asserting Q, the content of the second statement. Affirmation of the consequent is therefore Q. And when we get to the next one, here we've got denial of the antecedent. Look at the second one. The first one's always if P then Q. The second one here is not P. And the deductive chain here leads to not Q, and this is, again, a fallacy. Let's have an example. Same example. If I do well in the test, I will get drunk. I failed the test, so that's not P. It's the negation of the first proposition. If you then conclude from these that I will not get drunk, again, you're making a mistake. I'm liable to get drunk every weekend, whether I do well on the test or not. So this is, once more, a fallacy. So let's try and organize these four. There they are. And the last two had these fancy names, affirming the consequent and denying the antecedents. So let's put modus ponens and modus tollens, with their fancy Latin names, in the same language. We always start off with if P then Q, which I'm going to translate now as if A then B, the magic of symbols. So modus ponens has in the second line the assertion of A, the first proposition, and you can logically deduce B. So that's affirming the antecedent, the thing that comes first. Modus tollens had if A then B, and the second line was not B. So it's denying the consequence. The second proposition is consequent. Not B, therefore not A. And those are correct. If A then B, assert B and conclude therefore A, that is wrong. That is an affirmation of the consequent. And if A then B, not A, therefore not B, this is also wrong. That's denial of the antecedent. So even if A and B are both true, the first two ways of reasoning, modus ponens and modus tollens, are correct, and the second two are incorrect. So we've got kind of a structure now. We could go and set up experiments and check, are people any good? So here, for example, Marcus and Rips in 1979 gave participants in their experiment, who are always students in American psychology programs, gave them examples of arguments involving modus ponens, modus tollens, affirmation of the consequent, and denial of the antecedent. Those four. They were asked to judge each argument as valid or invalid, and they got it all 17 kinds of wrong. They often judged modus tollens, which was the second one, the second good one. They often judged that invalid, but the last two, the logical fallacies, were often judged valid. Now, what do you think of this research? Bear in mind, reason is playing an outsized role in the characterization of the human. Experimenters, faculty, thinkers, professors, have come up with this scheme to examine and judge students on their capacity for reasoning, and they're finding them wanting. Now, does this say anything about the intelligence or capacities of the students, or does this instead reflect a perhaps unacknowledged veneration of a particular style of reasoning that has become popular in the academy? Would you expect someone who hasn't been to university to do well on these? What are we studying here? Are we studying the obsession of professors, or are we studying the capacities of humans? We'll leave some of those questions for the next video, I think.